balloon with mass m is descending down. So let's imagine that this is our balloon and it is descending down. Okay, great. With an acceleration a. So acceleration over here is a, and a is less than g. Of course, it will be less than g, right? How much mass should be removed from it so that it starts moving up with an acceleration a? Okay, let's understand this, break this problem. So if this is our balloon and it is descending down, it is descending down because of what? Because of the weight, right? If the weight is very less, okay, compared to the gravity, okay, if weight is downward, okay, and buoyant force is acting upward, the balloon goes up because of buoyant force, right? We know that. Let's call it as B. B is the buoyant force. If the weight is greater than the buoyant force, the balloon will descend down. If the buoyant force is much greater than the weight, then of course it will lift up, right? So let me make a FBD here. Let's say the mass of the balloon is m and g. Oh, it's given. The balloon is having a mass m only. So m and g, weight is acting downward. Upward direction is buoyant force, right? Buoyant force. So if the buoyant force, if the weight, in the first case, weight is larger than the buoyant force, so the weight is larger, so mg minus b must be equals to mass times acceleration of this balloon, equation 1, right? Now the problem says you have to remove a little bit of mass from the balloon, right? If you remove the mass, the balloon will feel lighter, which means buoyant force becomes more than the weight of the balloon, right? So let's draw the FBD once again. If this is our new balloon, the same balloon from which we have removed the mass, the new mass will be m dash. We don't know, we have to calculate that mass. This is acting downward in direction and the buoyant force is acting on the upward direction, right? Clear? So if the weight still is higher than the buoyant force, it will go down, but the condition is what? That now this m dash is enough that buoyant force can overcome it, and buoyant force will make this balloon to go upward in direction. So this time look at the equation and try to understand that buoyant force is greater than this m dash g, and that will be equals to how much? M dash acceleration of the balloon, right? Now let me be very clear, m dash is the final mass of the balloon, but question is asking how much mass is to be removed, right? So m dash you will calculate and you will subtract it from m. That is the extra mass which you have to remove, right? Means m minus m dash, sorry. So this will be the answer. So let's first calculate m dash. So let's solve this equation. So what is our equation 1? Mg minus b equal to ma. So from equation 1, from 1, b will be equals to mg minus ma, correct? Let's substitute this equation in equation 2 at place of b. So it will be mg minus ma minus m dash g equals to m dash a. Sir, what we have to find? The new mass m dash. So this will be equals to mg minus ma equals to m dash a plus m dash g. Let's calculate here. Let's take common m dash, and that will be a plus g over here. And on the left hand side, let's take m common. It will be g minus a, right? Now m dash will be equals to m g minus a whole divided by a plus g. Clear? This is our new mass, but they are asking how much mass is removed. So this is our new mass, not the mass which is removed. So the mass which is removed will be, let me write here, mass removed. That will be equal to the previous mass minus the new mass. So m minus m g minus a whole divided by a plus g. Let's simplify it. Cross multiplying this will give us ma plus mg minus mg and plus ma whole divided by a plus g or g plus a, whatever you want to call it. Let's cancel out mg with mg and you left with twice of ma whole divided by a plus g or g plus a. This is the mass which we have to remove. Let's see if there is any option. What is the option? We got our answer as 2ma upon a plus g. 2ma upon a plus g. Option A is the correct answer for this one.